In the nightly theatre of the heavens, there's more to stargazing than the stars, the planets, and the moon. There are special acts, celestial vagabonds whose unpredictability makes them all the more exciting, cosmic show-offs such as meteors, asteroids, and, most famously, comets. Comets come from beyond the planets, exotic wanderers that for weeks, even months, can steal the show. Visitors like Halley's Comet, which appears just once in 76 years. Comets are the nomads of our solar system. Some travel on random elliptical orbits, hurtling among the planets. Kamikaze comets plunge into the sun. Others just graze its surface. To understand comets, we must travel back nearly 5 billion years to the birth of the solar system. From a primeval nebula of gas and dust, the Sun first coalesced. Then, from the heavier elements, the inner planets formed, solid little worlds like Earth and Mars. As the Sun grew hotter, it generated a solar wind. Upon it were carried lighter elements. They formed the outer planets, gas giants like Jupiter and Neptune. And far beyond, a third of the way to the nearest star, settled a vast cloud of icy debris. Like a shell enveloping the planets, it's so diffuse you could pass through without noticing. This is the Oort cloud, where comets incubate. Every so often, one is dislodged from the equilibrium of Oort by a twitch in the gravitational interplay between the Sun and its neighbouring stars. Thus begins a tumble toward the planets, the comet relentlessly drawn inward by the Sun. Tails of gas and dust develop as the comet reaches the inner solar system. Ices vaporize. They stream off as fluorescing gas, millions of kilometers through space. All of this from a nucleus that might be no bigger than a football stadium. The tails only exist within the inner planets as the comet bathes in the warmth of the Sun. And the gas tail always points away from the Sun, blown backward by the solar wind. As it swings round the Sun, this comet is returning to the cold outer depths, where its tails will disappear. From Earth, comets seem to hang motionless in the sky. In reality, they're travelling at many kilometres a second. But such are the stresses of the inner solar system that a comet nucleus may break up. With several fragments now streaming material, the tail can flare magnificently. In the wake of comets come shooting stars, properly known as meteors. As Earth intersects the trails of comets, dust burns up in our atmosphere, and meteors shower the sky. For a second or two, even a tiny grain can spark the heavens. Larger fragments, often originating from asteroids, produce fireballs, and, if they survive to the surface, they become known as meteorites. Set in silver at the base of a black structure called the Kaaba is possibly the most famous meteorite of all. In Mecca, at the time of the Hajj, millions assemble at this birthplace of Muhammad. Like Muslims throughout the world, the pilgrims pray toward their sacred stone, believed to be a gift to Abraham from the Archangel Gabriel. But there's a more prosaic view. Some scientists suggest the stone is one of the countless missiles that have pocked our planet since it was born. In other words, a meteorite, burnt black by atmospheric friction as it careened to Earth. Australia, a land of contrasts. Beyond the urban fringe lies a vast and open continent. With its arid climate and undeveloped landscape, the outback is a mecca itself for those who seek traces of meteorites. These are the Henbury craters, dug by a meteorite that had broken into a clutch of missiles. And this is Wolf Creek, blasted by a similar-sized projectile that remained intact. The crater is almost a kilometre across. The impactor was the size of a large house and probably metal. Were it less substantial, even a rock 20 stories high, it would have vaporised in the atmosphere. Wolf Creek is 300,000 years old. Gosser's Bluff is older, 140 million years, and 22 kilometres wide. Arizona, and another pockmark in the desert. This is Meteor Crater, gouged by a lump of nickel and iron 40 metres wide. The crater is well over a kilometre. 50,000 years old, it still speaks of cosmic energy. And that energy keeps coming. In 1972, this space rock, twice the size of the Arizona impactor, was caught on camera. Luckily, it skipped off the upper atmosphere and back into space. 1992. During high school football on America's East Coast, a fireball. It fragmented, and some chunks were recovered as meteorites. Here's the incident from Pittsburgh. Siberia, 1908. This projectile, 60 meters wide, didn't reach the ground. It exploded in the atmosphere with the energy of a nuclear bomb. Over 2,000 square kilometers of uninhabited forest was flattened. Had this happened over New York, millions would be dead. As our partner in space, the Moon is testimony to Earth's vulnerability. Lifeless and barren, no ocean, nothing hides these lunar craters, each one the print of an impact. The Moon has some 30,000 craters, uneroded by wind or water, a pristine record of wax from space. Per square kilometre, Earth takes as many hits. Strip away our atmosphere, our seas, our vegetation, and all geological movement, and this would be our planet. And were it not for Jupiter, Earth would take far more knocks. Jupiter, here with one of its many moons, acts as a shield to the inner planets. Comets that pass too close are captured by Jupiter's Herculean gravity. This one, comet Shoemaker-Levy 9, was pulled from its elliptical orbit around the Sun. The comet, a fragile mix of ice and grit, was drawn to within 50,000 kilometers. It paid the price. Jupiter tore it into more than 20 fragments, and that was just the beginning. Shoemaker-Levy 9 was to stage a celestial showpiece. The comet was to plunge into Jupiter and carpet-bomb the soupy atmosphere. From its perch in Earth orbit, the Hubble Space Telescope revealed a string of pearls. And because they were discovered well over a year before the event, astronomers had time to prepare. They'd watch as the multiple hearts of a comet hit a planet 1,300 times bigger than Earth. July 1994, and in New South Wales, the Anglo-Australian telescope was zeroing in. The week of the comet was at hand, and Shoemaker-Levy was performing brilliantly. As scientists had calculated, more than 20 pieces of grit and ice hurtled into the gas giant. Some were as big as mountains. But because the impacts were on the far side of Jupiter, just out of sight from Earth, observers had to hold their collective breath as the planet's spin brought the site of each impact into view. Patience and preparation were rewarded. Day by day, these heat-sensitive images displayed the aftermath of each impact. More than 20 major collisions at 60 kilometers a second. Some were bigger than expected. In Australia, astronomers awaited a grand finale.
Okay. K for Dave. K.
Oh God. It's going to be bright.
It was an astrofest. Front row seats at a celestial premiere with a nail-biting climax.
And then you'll see at the bottom of the image, one of them will get particularly bright, so it's at the bottom, at the very edge.
The impacts had come thick and fast. Each comet fragment had a letter. Tonight's vigil was for fragment W. David Crisp of California's Jet Propulsion Laboratory was team leader. As W approached Jupiter, tension mounted. Would the comet end with a bang or a whimper?
Yes!
It was a dazzler, a signal so bright the astronomers had to protect the telescope's delicate sensors.
Close down just a touch, Frank. Down to 2.3 probably. 60.
And now for the picture of the blast.
Wow!
Whoa, got it! Very dramatic.
That evening, Crisp's team had captured the best image taken on Earth. The string of pearls a month before collision, with fragment W in the ring. Impact time predictions had been spot on. And so had imaging. From Earth, here's a plume rising 1,000 kilometers above Jupiter's horizon. And from a spacecraft, the actual impact of fragment W and the resulting plume. For months afterwards, Jupiter sported its scars, and they could be seen through the smallest telescope. Were this to happen on Earth, the result would be catastrophic. The dark crescent in these pictures is a shockwave as large as Earth itself. Imagine if Shoemaker-Levy 9 had hit us. Long ago, another comet swung close by Jupiter. It too, like Shoemaker-Levy, had its orbit forever changed by the gravity of the giant planet. That comet was Halley. Today it travels on a long elliptical orbit that carries it out beyond Neptune and back again for a spin around the Sun. Thanks to Jupiter, Halley is locked into a 76-year cycle. It last came our way in 1986. It's due back in 2061. Our understanding of comets began with Halley. More than any other, it's helped unlock the mystery of their origin. The story begins in the 17th century with the English astronomer Edmund Halley. Halley's friend and compatriot, Isaac Newton, the great physicist and mathematician, developed the theory of gravity. Bodies in space, he deduced, didn't travel in straight lines. Instead, their motion was bent by the attraction of others. In 1680, Newton observed the motion of a comet. He worked out that it wasn't travelling in a straight line, but in an orbit around the Sun. So he suggested that a comet with a small enough orbit might be seen again and again. To test the idea, Edmund Halley analysed the sightings of 24 comets. Two important observations emerged. First, 3 of the sightings were separated roughly by the same 76-year interval. Second, these same 3 comets seem to have virtually identical orbits. Could they be one and the same comet, a regular visitor? If so, the next return should be in 1758. Sure enough, on Christmas Day 1758, long after Halley's death, the comet reappeared. It was named Halley's Comet. The revelation allowed astronomers to trace the comet back through time. One of these Chinese tomb drawings confirms Halley's appearance a century or two BC. A coin struck in memory of Julius Caesar also bears an image of Halley. It had been seen in the emperor's youth. This, from 648, is what people called a broom star. It's the same comet. In 1301, the Italian painter Giotto made Halley's comet the Star of Bethlehem. Halley wasn't seen that first Christmas, but some astronomers have suggested another comet led the wise men on their journey. By the time of Halley's appearance in 1910, the world of advertising had caught up with history's most famous comet. Early 20th century scientists greeted the return of Halley with a new tool, photography. But the pictures lacked detail. The comet withheld its secrets. 3/4 of a century later, Halley's comet was back. This was its space-age debut. In 1982, although still invisible optically, Halley was detected electronically. Then, through telescopes in 1983 and 84, Halley appeared to loop the loop, an effect of Earth's path around the Sun. By late 85, as it passed through Taurus, Halley could be seen in binoculars. A tail developed in December, and the comet was visible by naked eye. In January 86, the Northern Hemisphere had its best views. Halley was then lost for a while behind the Sun, before reappearing in the skies of the Southern Hemisphere. Observers had magnificent views from late February to mid-April, twin tails quite discernible. But the show was almost over. Halley had begun its return to the outer planets. Before it disappeared, however, the comet was investigated and probed as never before. From Earth and from space probes, data galore. Here, a head-on shot with spirals of gas trailing into space. The best images were recorded in the Southern Hemisphere. From the Chilean Andes, these show Halley after it rounded the Sun. And this from the unpolluted skies of equatorial Africa. A fuzzy cloud called the coma, clearly visible as it shrouded the comet's nucleus. A curved tail of dust that appeared yellowish to the naked eye. And a straight tail of gas, fluorescing blue over millions of kilometers. Another view from Africa. And for the first time, scientists did more than merely observe the comet. They reached out to it. As Halley sped past, an armada of robot spacecraft raced to intercept it. The most ambitious was a European probe named Giotto. Giotto was going for the closest of close encounters. It was to fly right through the inner coma, the cloud of dust and gas that surrounds the nucleus. And there was the nucleus. Like a peanut, a lump of primeval matter 16 kilometers by 9. Through the glare and fog, this was the very face of Halley. Vaporized by the heat of the sun, gas vented from cracks in the surface at 20 tons a second, dust at 10. The coma, fed by the jets, was well over 1 million kilometers across, bigger even than the sun. Giotto's transmission was knocked out with little more than 1,000 kilometers to go. But the probe had revealed a hardened shell of carbon black over an icy interior. From Earth, Halley put on its best show as it pulled away from the sun. Photographed over several months, the comet's tail lengthened and shortened day to day. Its overall brilliance fluctuated too. Astronomers attributed the variations to the solar wind, to changes in the composition of the comet's surface, and to the rotation of the nucleus. From the deep chill beyond Neptune to its tour of the Sun, Halley's surface had heated to over 90 degrees Celsius. In the late 80s, as Halley receded, so its image faded. Then suddenly, in 1991, it brightened. Could the comet have collided with something? We'll find out in 2061. By 1994, as it headed out past Saturn, Halley's comet was a few specks on a photograph. As we've seen, comets can originate in the Oort cloud. But some, like Halley, come from closer in, from just beyond the farthest planets. It's a region called the Kuiper Belt, and when Halley began tumbling inward, it was lucky. Instead of falling into the sun, Halley swung round it. But that means Halley is captive, locked in a vast ellipse that will take it round the sun again and again. At 76 years, Halley's orbit is relatively short. Longer period comets arrive from farther out, from the Oort cloud. Comets like Hale-Bopp, the most spectacular of recent times. Hale-Bopp, which appeared in 1997, has an orbital period of several thousand years. Here in close-up, Hale-Bopp's nucleus was 40 kilometers wide. It swirled gas and dust. They streamed from the hemisphere heated by the sun, switching on and off as the nucleus rotated. At its closest to the sun, Hale-Bopp shed 1,000 tons of dust every second. Little wonder there's less and less of a comet each time it passes the sun. Unlike comets, asteroids are from closer to home. Like a planet that never coalesced, they form a ring between the orbits of Jupiter and Mars, the asteroid belt. Made of sterner stuff than comets, asteroids are rock and metal, debris from the birth of the solar system. Within the belt, asteroids are harmless, but accidents happen. Collision, or a jolt from Jupiter's gravity, and an asteroid is knocked from its orbit. Drawn inward by solar gravity, and with a nudge from Mars, this space mountain is now a projectile. 65 million years ago, this is believed to have happened. 10 kilometers of rock and metal were on a collision course with Earth. It was doomsday for the dinosaurs. Earth suffered a cosmic winter and mass extinction. At least 100,000 dislodged asteroids cross the orbit of Earth. 2,000 are big enough to cause us problems. This one is Eros, 40 kilometers wide. So real is their threat to Earth that NASA commissioned a probe to Eros to analyze and image the asteroid from every angle. In 2001, the probe landed on Eros, the better to make its acquaintance. Were we hit by Eros, nothing. No life on Earth would survive. The worry is that for every asteroid plotted here, 20 or more are yet to be discovered. So what could we do if one were headed our way? It's still science fiction, but we could build a parabolic mirror. Towed into space, it could concentrate reflected sunlight on an intruder and scorch it off course. In another concept, giant pods might close with an enemy asteroid and attach to its surface. They would release supersails that caught the solar wind and tugged the intruder away. Or how about this device? Like a celestial outboard motor, it could shunt the object to a safer course. But suppose there was too little warning. A space rock would hit us in weeks. Would we go for the nuclear option? It would be a last resort, either as a standoff blast or a direct strike. Who could predict if it would save the world?